So let's continue talking about the transformations of the sine and cosine graphs. For our next example, or on example 4, let's graph the function f of x is equal to sine of x minus pi plus 5. So we have a couple of transformations going on here. First of all, this minus pi inside of the parentheses, remember if we add or subtract a number to x inside of our function, what this gives us is a horizontal shift. And if we subtract a number, remember that's going to shift our graph to the right. If we were to add a number, that would shift our graph to the left. And this plus 5 on the outside of the function, well, that's going to be a vertical shift. And because it's a plus 5, that means we are going to shift up 5 units. All right, let's go ahead and start to draw this. And I gave myself so much room up here above the x-axis because I know that I'm going to have to shift up 5 units. In fact, I'm going to go ahead and just kind of label 5 here on my y-axis. All right. Now let's also identify some other things about our function. For example, the amplitude. So remember, the amplitude is just the height of a sine wave. And in this case, our height here would just be 1 because the amplitude comes from that coefficient in front of our function. So here our amplitude is 1. Our period, remember our period is given to us by the formula 2 pi over b, where b is just that number in front of x. So in this case, b here is 1. So I get 2 pi over 1, which is, of course, 2 pi. Okay, so my period is still 2 pi. What else do we have? Oh, we have this horizontal shift to the right by pi units. So we're going to start over here at an x value of pi. And by the way, instead of calling it horizontal shift, which that's what it is, but kind of our fancy term for it in terms of sine and cosine graphs, we call it the phase shift. So the phase shift is just our horizontal shift. And since we're shifting to the right by pi units, our phase shift is equal to pi. Right? And remember our period here is 2 pi. So that means that the length of our full cycle is still 2 pi, which means if I start at pi, that's the beginning of my cycle, well, what is 2 pi later? Where is my cycle going to end? Oh, 2 pi later would be 3 pi, right? And this gives us the length of our full cycle, which is still 2 pi. All right, now what I need to do is break up this interval into 4 equal segments. So, well, what's halfway between pi and 3 pi? That would be 2 pi. What's halfway between pi and 2 pi? Well, I would just take their average. So the average of 1 pi and 2 pi is 3 pi over 2. Same thing over here. Halfway between 2 pi and 3 pi, we'll just take their average. If we add them up, we get 5 pi, and then divide by 2. Now, another thing, we have this vertical shift of 5 units. And so before, remember what the sine function did is it started on the x-axis, and then it went up 1 unit, back down to the x-axis, down 1 unit, back up to the x-axis. We're going to get that same kind of shape, but instead of being kind of centered around this midline, which is the x-axis, our midline is actually going to be up here at y equals 5, because we shift everything up 5 units. So here we go. This is called, we can call this the midline. And so our midline is this horizontal line, y is equal to 5. Okay. Now let's actually start plotting our points. Now remember the pattern for the sine function is, again, we start on the midline. So this will be our first point at pi, comma 5. Whoops. So this is the point, pi, comma 5. And then, I just did it again. It's just pi, comma 5. And then what do? We go up 1 unit. Remember, our amplitude is just 1, so we'll only go up 1 unit. So now we're up at this point. This would be the point 3 pi over 2, comma 6. And then we come back to the midline. So this is 2 pi, comma 5. And then at 5 pi over 2, we're going to go down 1 unit. So what would this be? This would be a value of 4. So what we have is 5 pi over 2, comma 4 is that point. And then finally, we'll finish our cycle by ending at the midline again. So this is 3 pi, comma 5. And if we connect the points, we get our familiar sine wave shape. And of course, this could continue to the right and to the left forever, but this gives us at least one full cycle. And by the way, let's go ahead and identify the domain and range here. So the domain, that's going to be the same as always. All these sine and cosine functions, domain is always all real numbers because we can plug in any angle we want in radians. But now if we take a look at our range, well, what do the y values range between? Notice our lowest y value is 4, and we're going to make sure we include it because we actually attain that value. And what's our highest y value? Oh, we go as far up as 6, and we'll include that as well. All right, a couple more examples for you. Example 5. Let's now graph the function f of x is equal to 2 times sine of 1/2 x plus pi plus 3. All right, so now we actually have kind of all the transformations going on that we could possibly have. So let's start by just identifying our amplitude, period, phase shift, midline, all of those things. And I'm going to start with the phase shift, just because that kind of tells me where we're going to start our cycle. So I'm going to identify all of these aspects kind of in the order that we're going to use them. So our phase shift here, remember, that's just whatever we're adding or subtracting to x. Right? In this case, we have a plus pi, which means we're going to shift to the left. Okay, so we're going to shift left, and we're going to start at negative pi. Right. All right, and let's go ahead. I'm going to make my graph over here. And I'm going to give myself a little bit of room above the x-axis because I know that we're going to end up having to shift up 3 units in the end. Right. In fact, I'll go ahead and label that. Okay. Yeah, let's go ahead and just write down. We know that our midline here is going to be y equals 3, right? Because we're shifting everything up 3 units. I can go ahead and plot that. Oh yeah, so this is y equals 3. There's our midline. Also, we said that our phase shift is negative pi. Let's go ahead and plot that. Negative pi, that would be over here. So this is where our cycle is actually going to start. Okay, what else do we need? We also want our period. So what is our period? Remember, our formula is 2 pi over b, where b is just our number in front of x. So this guy here is b, 1/2. So what we have is 2 pi over 1/2, which, what is this? This is 2 pi. Now dividing by 1/2, that's the same as multiplying by 2 over 1. So what we actually get is 4 pi. Okay, so our period now, it's now 4 pi. So that means if I start at negative pi, well, what is 4 pi later? Well, let's see. 1, 2, 3, 4. This over here should be 3 pi, right? If I do negative pi plus 4 pi, that should bring me to 3 pi. And now we can label all of these x values in between. I know halfway between negative pi and 3 pi. Again, we can just kind of take their average. If we add them together, divide by 2, what we would get is pi. Halfway between negative pi and pi is 0, and halfway between pi and 3 pi is 2 pi. Okay. Oh, and one other thing, what else? We have our phase shift, our midline, our period. We also need our amplitude, which is positive, and in this case 2. Right? Remember A here, that gives us our amplitude. All right, so now let's start plotting our graph. So remember, we start on the midline, and then the sine wave goes up, back to the midline, down, back to the midline. Right? Okay, and when we travel up, so we start on the midline, so this is negative pi, comma 3. When we go up, this time we're going to go up 2 units because our amplitude is 2. So we'll have the point 0, comma, what is 2 units above 3? That would be 5. Okay. And then we come back to the midline, so this would be the point pi comma 0. Oh, not 0. Our midline is 3. And at 2 pi, well, now we come below the midline, and we're going to come 2 units below. So 2 units below 3 would be, this would be the point 2 pi comma 1. And then finally, we'll end back up on the midline. So this is 3 pi comma 3. And here we go. We get one full cycle of our sine wave. And just for completeness, let's just write down the domain and the range here. So let's do it down here. Domain, same as always, all real numbers. And our range, let's see, our y values, the lowest y value is 1, and the highest y value is up here at 5. So our range is 1 to 5. All right.